Happy families are all alike. Every unhappy family is unhappy in its own way. That's how Tolstoy started his Anna Karenina novel. So how does it relate to us here in data analysis? Well, it turns out that we have some defined characteristics for what we deem as tidy data. For example, in rectangular data structures, every variable, attribute, feature forms a column, every observation forms a row, and every observational unit forms a table. But if we think about what we could consider as untidy table, there are too many possibilities. You could have those rows that are merged to act as separators. You could have tally rows. You could have column headers that are not really column headers, but more of a table description. All of these are issues that we have to tidy up before we can start with our analysis. But data generally don't come in a structured state in the first place. Text and images, for example, they need to be processed first, they need to be manipulated first, so that we can represent them as a set of features in a tabular structure. Let's take this picture example. At the end of the day, pictures are really just a group of pixels put together. And every pixel has an attribute of RGB for colored pictures, and maybe on and off like bits, 1 or 0s for black and white pictures. If we wanted to represent this picture here in a rectangular data structure or in a data frame, and let's assume here that we have 0 for white and 1 means red, we can have this table here. However, would this fit the description that we had for what we would deem as tidy data? Well, no. Rows and columns here are really basically a matrix, and we still want to convert that to a table where we have the X and Y as columns and maybe an additional column called isRed for to indicate whether the cell needs to be red or not. Rectangular structured data is only one common form of structured data in general. By no means we're saying that this is the only one. Actually, what we could consider as tidy data for one analysis project may not be for another one. For example, spatial data, which are used in mapping and location analytics, or graph and network data that are used to analyze relationship between entities like in social media networks, for example. So by no means we're saying that rectangular data structures are the only acceptable forms of structured data for analysis. It really depends on your project, and you'll want to choose what is right for your data and for your analysis. By the way, what we've done here, converting this image from its raw state or raw format into a data set, is what we call data wrangling. So when we convert an image to a data set or parse server log files to analyze web application traffic, really in constructing this data set, we're also defining the data types for each one of those columns or each one of those features. Just looking at this same example here, we could see two different data types here, numerical and categorical. But let's talk about that in the next video.